there are still a lot of producers producing long-lasting parts from plastic, but I think the majority is still struggling with this problem of creating products which are supposed to last just for one-time use from a material which is made to last forever.
My name is Patrick Hübscher, and this is Circularity FM, the podcast about understanding, building, and managing circular business models. Welcome to a new series. What is one of the most important factors influencing circularity? Product design. It's frequently highlighted, but I feel it's underreported. Therefore, I'm happy to dedicate one series to this topic. I don't do it alone. I do it together in partnership with a knowledgeable and well-esteemed organization, the German Design Council. It's a leading authority on design already since 1953. As a thought leader in the field, the GDC is committed to realizing the potential of design for a sustainable future. So it's not design for the sake of it. It's design as an instrument to be successful in business. One of the formats they're driving is the Circular Design Summit. The next one is coming up end of March this year. If you're interested, check it out at their website. You can find the link in the show notes. So, GDC, thanks for curating this format together and providing me access to the speakers of this series. In this series, we follow a simple structure from small to large. We start in this episode with the material dimension. Then we follow with the product before we finish off with the business model and the organizational aspects. As an orientation, we will use the circular design principles developed by the GDC together with the Wuppertal Institute. But before we start, I have an offer for you. If you want to get the actionable one-pager about this conversation, sign up for the Circularity FM newsletter. You can find it at www.circularity.fm. He studied automotive engineering and product and engineering design. At the beginning of his career, he helped industrial companies to engineer and design machines. 18 years ago, he joined BASF, where he held various positions, among them also as a team lead in the Design Fabrik. Since more than 6 years, he is BASF's head of Creation Center in Europe. Welcome, Andreas.
Hi, welcome, Patrick. Great to meet you.
Andreas, it's a privilege to talk to you as someone who has a design background but works in a more or less chemical company. But before we look at the business, what's your preferred material?
So my preferred material is the mix of materials, so different material. I think every material has its place, and the interesting thing is playing with different materials instead of focusing on one and trying to realize every idea of one material. But I think we come to that point later.
Yeah, that already sounds like a good fit to your profession. Before we start, can you give us a quick overview of what is the scope of BASF's product range, if quick is possible?
I think that the problem starts with the scope, because actually there is more a scope in the resource than in the markets, because the BASF produces and is more or less one of the only companies in the world which is still having such a broad portfolio and create materials for all types of industries, for all types of applications, that ranges from base chemicals, agricultural products such as fertilizers, but also dispersions, which are used for all types of paints. BASF produces vitamins. Some of the more or less better known products to the public are products like AdBlue or Glycentine or Styropor, and at the end, and that's where I am based in, the topic of plastics and foams. So styrofoam is one of them, but also polyurethane or other special foams. And so it's a really, really broad range, but it's all somehow deriving, at least in the past, it's deriving from crude oil or at least fossil-based raw materials. And that's the topic which is changing extremely at the moment, especially for BASF.
Okay, nice. That sounds great. Now, I said you're head of the Creation Center in Europe. What's the role of the Creation Center?
The role of the Creation Center is to provide an entry gate to this huge BASF world, especially for all types of creatives and innovators, with a clear focus on the plastic materials, especially if you do not exactly know what material to use. You need somebody who is taking care about you to help you with choosing the right material. And we have all types of designers, engineers, also scouts from various industries coming to our place to see what we are having in our portfolio, but not only that, but also working together with us and creating new applications for the materials, to work on existing applications. And basically we try to support customers. That's the focus, but also people who might become customers in future, from their first idea to a solution.
Okay. So to me, it sounds a bit like you're a translator, translating the needs of the customers or potential customers into what it means in terms of material, and the other way around.
I think that probably describes this pretty good. Very often the technical colleagues do not really understand what are the needs of, for example, product designers. So if you have a product designer coming to the place and say, like, I'm searching for a material with a froggy surface, most of our engineers are somehow lost, and we try to figure out what that means in terms of material. Especially for cases like that, we do have a huge material library where we do have all our products and samples of our products provided to guests to really find out by touch and feel and experience the material whether this is the one they are searching for or not.
Yeah, it's always the same story in every fairly big organization, that you need people translating between the different functions. We're kicking off a series with our interview here, which we're doing together with the German Design Council. And the German Design Council applies 4 principles when it comes to circular design. And these 4 principles are: we think, reduce, reuse, and recycle. Today we will focus on the material aspect. And let's start with reuse. So from your perspective, how can you support designers to, let's say, extend the product lifetime, which is kind of a prerequisite for reusing a product?
So I think that topic is known since years, that the reuse of materials, especially talk about plastic materials, is it has a really long-lasting story. It started already in the 80s, where first ideas of using plastics came up. And the interesting thing is that a plastic material, as most of the people understand it, are thermoplastic materials, which means you can melt them, and by melting them, you produce a part. And if you have the part, you can melt the part again and recreate a new part from it. Actually, that's the fantasy that a lot of people are having, but the reality looks very much different. And this is exactly the job that we are doing, and a job that is getting more and more important since years. That we are trying to get solutions which are coming closer to that fantasy. I think we did some really big steps towards this direction, but we are still not there. So we help them on the way to extend the product lifetime, and this is coming from the materials side, but also it's a matter of the chemistry and the whole infrastructure.
And just help me out here, because when you say melting the plastic, that to me sounds a bit like more in the direction of recycling, which we'll also touch upon. How does this capability make the product lasting longer?
I think it's as you said, it's a prerequisite for really reusing things and to be able to disassemble them, because heat is kind of a trigger which helps to remove parts that you might not be able to use anymore because they are broken, because reusing means also refurbishment. And refurbishment is the one part of prolonging the lifetime of a product.
Is it also a topic in your team and with customers to find the ideal point in time until which a certain material and product should last? Because ideally you want to keep it lasting for a very long time while it is in use. However, when it's kind of discarded or not used anymore, you don't want certain materials to last any longer while they're out in the environment, or could cause any danger. So it kind of, the needs depend upon the context in which the material is active, so to say.
I think that's the trouble that we are in at the moment. We are not able to get rid of the materials because the material itself was made to last long, but the product was not thought to be a long-lasting product. If you look back in history, the invention of the plastics material came with a really, really good sense of creating a solution for replacing natural materials, like material coming from turtles or elephants, and replacing those materials with a cheaper solution, but also a more sustainable for the environment at that time. And in a second step, we found out that it's now possible to come into a mass production. So we created masses of products from this material. If you look at advertisements from the 1970s, where the producers for dishes, for example, said, "Okay, this is the solution for the housewife of the future because you do not need to wash your dishes; you just throw them away." And this is real serious advertisement at that time. And this is, it might have been a good idea in the 1970s, but if you look at it from today's perspective, it's just completely idiotic, because these plates from the 1970s, you can still find them if you dig in your garden, and they do not degrade. And that's the problem. And there are still a lot of producers producing long-lasting parts from plastic, but I think the majority is still struggling with this problem of creating products which are supposed to last just for one-time use from a material which is made to last forever.
It kind of brings us to the second circular design principle, which is about recycling. Because what we're starting to talk about is the recyclability of your material. So how can you support product designers who want to build a product that is highly recyclable?
We discuss with designers how to create these loops and how to separate the different plastic materials from each other. It's a lot about adhesives, debonding, about how to attach parts with each other, about one materials or using less materials. So that's the one side, and the other side is that there are still many non-thermoplastic materials out there, which are still a big issue, because especially if you think in terms of polyurethanes, which is widely used for all types of upholstery, mattresses, whatever. So the volumes of polyurethanes are tremendously high, and this is a material that is not thermoplastic, so it's a thermoset material, and therefore uh, we are supporting by doing research on that topic and find a solution of making this recyclable in a way that it's also sustainable and affordable as well.
When we come back to the first one, the thermoplastics, you said in principle it's possible to recycle them, but in reality, one of the first challenges is that you normally have a mix of different thermoplastics. And if you then want to recycle them, ideally you need to separate these different kinds of thermoplastics first. So what are ways to help, let's say, product designers there to facilitate that separation at end of life?
I, Interestingly, the first thing that you should tell people is that plastic is not plastic. So there are so many different types of plastic, because a lot of people think, okay, it's all somehow plastic, and you put it together. That was the idea of the yellow bag, the gelb Sack in Germany, where they said, okay, you put all plastics and aluminiums in one bag, and then it's very easy to separate it, and you can reuse and recycle it very easily. And that's a very naive thought here, because you really need to separate the plastics, and not only to separate the different plastics, but also to separate them by color, but also by their contents. So some of them are using stabilizers or certain types of flame retardant agents or whatever, and you cannot just mix them and create a new product from it. So you really need to sharpen the consciousness of the designers to understand that these different materials need different ways of recycling, and that there are also some thermoplastic materials that cannot be recycled at all, probably, and it cannot be recycled for every product. So I'm sure you do not want to have flame retardants materials when I'm talking about medical devices. So these are things that do not fit together, and that's the important questions, really, or the important topics that to be discussed with the designers in a first approach. And in the second approach, it's to tell what are these materials, and how can they really be used for, and what are also the limits of a recycled materials. Yes, yes, and not like you have it very often that you it's a, for example, a for the perceived quality of a material, a two-component molding is very interesting, because you have a soft component and you have a hard component, and you use the hard component for structural parts, and the soft one, for example, for haptics and the comfort. Like if you look at the drilling machine, you mix those two in one part. It's a two-component molding, and it's really different to separate them afterwards again. And so you need to find ways to avoid that, or to make it in a different way.
Are there good examples you can share from your work or from the wider industry, where you say this is where the material separation worked pretty nicely?
I think the furniture industry is in a certain way already an industry which is pretty far in terms of separation, because they are still thinking a bit like carpenters, and they put together materials still with screws, and use a lot of, for example, if you have your upholstery, they use still zippers and everything. But on the other hand side, especially when it comes to the durability And this is usually a sign of quality, means it needs to be durable. And durability comes a lot with bonding. So if parts are separating when you do not want to have them separated during the lifetime, then you very often need somehow adhesives, which uh, are really made to last forever in their compound. So if you glue together some things, you want to have it together for the whole lifetime. And so we need to discuss how to come to that. And so in the furniture industry, they already, or you can already see that there is a little stepping back uh, into this, but this already causes the first quality complaints from their customers, that they say, okay, now the foam separates from the wood, but exactly that is the target, because they do not want to have these two parts glued together. So you need to find a way of creating that, and we are together with customers in the furniture industry developing adhesives that you can separate at an elevated temperature. When it's okay, which is, for example, 80 degrees C. If you go beyond 80 degrees C, you can separate it again. So the classical, like the plastic glue guns, work a bit like that, but it's all a matter also of price, and you need to have a material which also suits into this whole um, range of separated parts, because the glue is a third material in the whole game, and it needs to fit either to the one or the other material, so that you can avoid to have three materials instead of two.
I can imagine that most of the value comes when you deeply go or intensively collaborate with the design teams. How much do you then also look at the recycling techniques? Because many of the things you talk about kind of presume the ability, or at least the knowledge about a certain recycling technologies, because this is where ultimately the recyclability will be decided.
That's a very, very important thing for us, because the technology also decides on the quality of the material for the second use phase. And if you are not understanding the recycling technology that is behind, you cannot improve the material to this special way of recycling. But the the easy way of mechanical recycling that we are talking about is like grinding old plastic materials, melting them, is just one way of doing a recycling. So you can also use solvents. You can use even so-called chemical recycling, where you split the polymer chains to new monomer chains and rebuild the polymers again. So there are so many different ways of recycle things or plastics that really need to look at the different routes that you can take, because every route has somehow a reason for being there, and there will be at the end not the one recycling technology that solves all our problems, because the recycling always consumes energy, and you always need to compare the energy you need to put in to recycle with the energy that is used for creating a new material. And so it's always a balance. And that's why we really think in all directions of technology, and we provide materials for all types of recycling process.
Let's move on and look at the other side of recycling. We already started talking about it, and this is like the recycled material, because at the end, if at the end of life the material gets recycled, it's only because there is another use for this material. Is this something you also provide, and for what kind of cases?
Yeah, we do provide all types of recycled materials, ranging from post-consumer materials over post-industrial recycled materials to chemical recycled materials. So that this whole range can be found in our portfolio, and it depends on the application and on requirements of the customers. As I said, it always comes along a um, a life cycle analysis of the material, because you to see, okay, what is the energy being used for producing these materials in the one or the other recycling route. Um, and depending on the requirements of the customers, we can choose one or the other recycled material. Um, there are examples from customers like Siemens or Eaton that really produce uh, high, highly safety relevant parts like circuit breakers. You don't want to have them fail, or also the automotive brake pedals, for example. You don't want to have a fail in your brake pedal, but you want to have that they are using a recycled material. And now you need to find a material that provides the same quality as a fossil-based virgin material. And so you need to somehow see what are benefits, what is your ratio of energy consumption, or product carbon footprint, and so on. And you need to somehow balance all that and see, okay, what is the possibility that I'm having. And if possible, I go for a post consumer recycled material, because that would be like the preferred option. But maybe if you come into the third or fourth circle, it might not be of the same quality like it is in the first circle. And there are also possibilities from a chemical point of view to improve materials. For example, the polyester industry. So what you know from the PET bottles, uh, they have solutions to improve the molecules and to improve the polymers again, and to make them virgin-like in the third or fourth circle. And so it's a really complex field of possibilities. And I think that's also a reason why you need a lot of support from a company as BASF, because as a designer, you cannot oversee all these possibilities.
How would you name the typical barriers when it comes to using recycled material?
Cost is very often a point of discussion, but it's also the product quality, product safety. You have a product which has some kind of a critical application. Let's talk, for example, about the medical industry. They do not want contamination in material. And how can I, as a material producer, BASF, give the guarantee that we keep the same quality of material over years? And this is something where they need somehow insurance from us, because they know that we are having to change our sources of the raw material. So one time we get probably the raw material from old carpets, then we get the raw material from airbags, from cars, then we get the raw material from old dashboard. And so the source changes. And if the source changes, the contamination also changes. And this is something which is very important to know. And a discussion that is now starting, since the whole recycling is becoming more and more common, is the discussion about the uh, um, resource, not the quality, but how constant. Uh, if I look for a resource, let's name it carpets, somehow the number of carpets that are thrown away every year and can be reused for recycling is limited. And now what to do if tons of carpets are now recycled and in the loop? So what? So what to do if ABSF says, okay, so there are no carpets anymore? Prices rise dramatically for old carpets. It's a situation that we are already seeing in the pet industry. Um, so what is happening? Because a lot of plastics, which is used for the plastic bottles, is now going into textiles, which causes a lot of trouble for the bottle industry. Because they are losing their resources of recycled material because the textile industry pays more for the PET than the bottle users. And so it's a very interesting situation and completely new to many of us because it changes the game completely.
Andreas, do you have any other, let's say, positive example where a product or company uses a high share of recycled content?
Actually, I have at the moment no example of a company of using really a high share of mechanically recycled content because it's all in a very, at least in our customer structure, because we are more or less serving um, customers with so we are selling engineering plastics, which are for structural components, and they are the reliability of the material really plays a crucial role. When it comes to packaging, there are already companies really using a lot of recycled materials. If you look at Procter and Gamble, a lot of their packaging materials are already, because they are forced to, are already using a lot of mechanically recycled plastics. In our customer group, we do not see that very often. We have a lot of customers, or more and more customers, using a wide range of chemically recycled plastics. And we have the first, which are more on an experimental level, customers using mechanically recycled plastics from post-consumer and post-industrial resources. We just started with IDRA, a project about recyclable polyurethane foams, and they switched their whole polyurethane portfolio to this new foam, but they are not using a recycled polyurethane foam because there is no at the market. So we first need to generate the waste, and then we could use the waste for creating recycled material. But the waste stream is still not there.
Two examples I can provide. So in the previous two episodes, we heard from VZUG from Switzerland, where they used mechanically recycled plastics for their covers for washing machines and wires. And another one, Bosch Power Tools, using that for the housing of a power drill. But here also, to be fair, it's about getting started. I mean, for VZUG, they're starting serial production of that this year, but still, yeah, it's in the early days.
Yeah, but you have to start somewhere, and I think it's good to see that big companies like Bosch that they are really taking efforts to doing really these experiments. And we are also we work with Inditex, so the company behind Zara, to create a polyamide based jacket, which is also able to run in a loop. But it takes some time because you really need to find out what are the waste streams, how does it work, and you just collect experiences, and you cannot do that theoretically.
Andreas, let's come to the last principle we want to cover, and this is rethink. Everyone who listened up until now already realized that it needs a lot of thinking and rethinking when you want to design a circular product, because you have to look at the whole life cycle and technologies involved and so on. What are typical measures you observe where designers can rethink the product to improve circularity?
There are also different ways of rethinking. One is more the business model design, because as soon as you start making your products lasting longer, or if you go into reusing and refurbishment, to rethink how to earn money with your company, because your products, they will be hopefully in the market forever. And that's also one reason why we have a lot of disposables, because the people or the companies earn a lot of money just by things that were thrown away and had to be bought from new. Um, and by that, you need to see, okay, how can I earn money, not with my product itself, but how can I earn the money with the reuse and refurbishment? And today, uh, there are specified companies which are earning money with the business model of refurbishment, but these are not traditionally not the OEMs. And so that is one point, and I think this is also something that the designer uh, needs to think about when he thinks about the product. It's not only about how does the product look like and is it recyclable, but also how could my customer, so the OEM that is asking me to design the product, how can he benefit and profit from the design in terms of product which can stay in the loop and generate money. Um, that's the one thing. And the other thing is, I think that's even more important, is also to somehow create designs which tell already in the appearance the story of the recyclability. We have a lot of designers come to us and asking, could you put in some speckles so that it looks a bit more recycled? And this is not the right way to do it. So in the past, it was very important to provide an appearance of quality by the design. Now it might be the time to provide an appearance of sustainability by design. And how can I make a product look recyclable or reusable without somehow tweaking the material? And that's a real challenge, because we didn't see so many projects where it worked so far. And also you need to explain customers that it might be fun and a cool thing to use a more sustainable product, and to reduce the fear of renouncing something. So a lot of the products are disposables because it's so easy. You know, it's like you use them, you throw them away, so it's very clean. You do not have to wash your dishes anymore. And so somehow you need to tell the people that it's not only good for your karma, but it's fun that you are doing it that way, and that you are doing it with a recycled product, and increase the value just by the usage and the experience that you are having with the material. And when you think in terms of additives and plastics, for example, if you leave out UV stabilizers, the material will yellow over time. Um, it will not have an impact on the mechanical strength, but it looks kind of ugly. But who tells us that the yellowing is ugly? In the past, it has been the designer who said it needs always to be this bright white thing, you know. And by that, I think it needs some cultural change of thought, and that can be really carried out by a really good design and the possibilities that the designers bring with them to express product values by the appearance of the product.
Yeah, that sounds like a promising future. And then again, it reminds me of the last conversation where we also discussed where does the requirement come from that washing machines and other home appliances need to be purely white. Yeah, and this is why there's a culture and identity of the white goods industry. Yeah. But I mean, the brown goods industry is also, I feel, black by now, or I don't know.
Yeah, it's black or metallic. So it changes, and it has a lot to do with the design. And so I think one interesting example is also, again, cars. So somehow you told people that it's cool to have a car running 200 kilometers per hour. But why not creating a car? And that was the project that we did with Citroën, like telling the people, okay, that's a fun car, and it's okay if it just goes 100 kilometers per hour. And I think this is some story that needs to be rewritten.
Yeah. Yeah, I'm sure that speaks to many designers' hearts because it resonates with the ambition to not only select materials, but design an experience, design the overall lifetime and environment ecosystem around the product.
But I have to admit that from these many discussions that we had with designers in the Creation Center, the designers mainly are already there. So they, I think, understood this idea, but it's still a lot of marketing people and also so the OEM management, they still think in very, very conservative terms and still are fearing of changing too much into the other direction because they might lose business.
Yeah. And at the same time, it's an opportunity to tap into, and the first one who will do that successfully will, get the reward. Andreas, thanks for this journey. I feel like we could go on for another hour, but let's leave it here. If anyone is interested in reaching out, how to connect with you?
You can find us in the internet if you look for BASF Creation Center, and you will have a contact form there, or you just can write me personally an email, andreas.maegerlein@basf.com. We are open for all discussion. We are there. We try to help where we can. Sometimes we cannot, but sometimes this is also a help if we tell you to don't use plastics for your applications. And it's good that it's like that still.
Yeah. Wonderful, Andreas. Thanks for sharing your experience.
Thank you very much. Thanks for inviting me.
This was the first episode in our series on implementing circular design principles. If you want to get the actionable one-pager about this conversation, sign up for the Circularity FM newsletter. You can find it at www.circularity.fm. You want to learn more about circular design? Visit the GDC's Circular Design Summit. The next one is coming up end of March in Stuttgart, Germany. I'll be moderating a panel, so maybe we see each other there. Let's drive a profitable circular economy. And please don't forget, the most abundant renewable resource is your imagination. My name is Patrick Hübscher, and this is Circularity FM, the podcast about understanding, building, and managing circular business models.